An e-commerce platform uses an AWS serverless architecture with Amazon API Gateway, AWS Lambda, and an Amazon RDS for PostgreSQL instance. During a recent high-traffic event, the application performance degraded significantly. CloudWatch metrics showed a surge in Lambda executions and simultaneous database connections, alongside high database CPU utilization. Which strategy should be adopted to handle high-traffic bursts? Option A, increase the memory for the Lambda functions and update the code to explicitly terminate database connections immediately after each query.
Option B, implement an Amazon Elasticache for Redis layer to cache frequently queried information from the RDS database. Option C, deploy an RDS proxy instance and update the Lambda functions to point to the proxy endpoint for database access. Option D, update the Lambda logic to maintain database connection persistence outside the primary handler method and verify existing connection status before initiating new ones.
This scenario focuses on architectural patterns in serverless environments. It addresses the challenge of managing database connections when using ephemeral compute resources like Lambda. Because Lambda functions are short-lived and scale horizontally, they can quickly overwhelm a traditional relational database by creating numerous concurrent connections, which leads to connection exhaustion and increased CPU load on the database server itself.
In my view, the correct answer is option C, deploying an RDS proxy instance. This is the most effective solution for managing connection counts and CPU load in this specific architecture. When many Lambda functions trigger concurrently, they each try to open a database connection. This exhausts the database connection limit and spikes CPU usage due to connection overhead. RDS proxy acts as a managed pooling layer between your application and the database, allowing functions to reuse existing connections.
Regarding the other options, option A is inefficient because explicitly closing connections on every retrieval actually increases latency and processing overhead, while option B, using Elasticache, can assist with read-heavy workloads. It does not directly solve the core issue of connection exhaustion causing database CPU degradation. Similarly, while option D discusses connection management, it fails to prevent exhaustion when numerous concurrent execution environments are launched simultaneously.
For your certification exam, remember that whenever you see high traffic bursts causing database connection exhaustion in a serverless setup, look for connection pooling as the primary remedy. RDS proxy is specifically designed to handle these concurrency challenges without requiring significant code changes to your application logic.